When you're running an experiment, what are times that we should prioritize speed over the probability of a false positive? Basically, at what point should we adjust the threshold for statistical significance so that it's not necessarily p equals 0.05? First, I'm going to give you a little bit of intuition and then some concrete examples in both ways. When I'm giving mock interviews and we talk about the power analysis, almost everyone uses p equals 0.05 as the statistical significance threshold. And I give them an example and I say, okay, let's suppose that this happens and you get a p-value of 0.04 for the treatment effect. What would you do? They would say ship it. And then I ask them to describe it, right? And the p-value is the probability of observing this treatment effect, the gap between means, by chance alone, if the null is true, if there's actually no effect. And then so I say, well, what if that probability was 6% or 7%? And almost every single time, the candidates would say, oh yeah, that's still pretty good. Like I would probably ship it. And so you should see intuitively how that's incongruent with choosing in advance this alpha threshold of p equals 0.05. So let's give a couple of examples. Let's say you're an e-commerce company and you want to do email marketing for the upcoming holiday season. And right now your email marketing is, we're going to send them an example of our most popular product that we have, in our store, and we're going to see if that gets people to buy. And your alternative, your treatment, is a different creative that maybe uses a machine learning algorithm to predict what product you might like. And intuitively, the company already thinks that this is a good strategy. So imagine you run this experiment and you get a click rate or an open rate of your email, and maybe even a conversion rate that's higher in the treatment group, but you get a p-value of 0.08. What does that mean? Imagine telling your stakeholder, hey, we have a 5% higher lift in this new email marketing campaign where you give a recommended product based on some machine learning algorithm, but there's an 8% chance that we obtain this by chance alone, and then there's no effect. Imagine if you told them, don't ship it. Like, we're going to use the old email, even though we tested this, had a higher open rate or higher click rate with this new process, this new algorithm, this new email campaign, and there's an 8% chance that it's a false positive of no effect. The stakeholder would look at you like you're absolutely crazy. And for speed, you can imagine why the holiday season is coming up. If you were to run this experiment now, you don't want to run it for 2 months. You'll miss the entire season. So what about the reverse? What about one where we really do want a conservative p-value, alpha value? Imagine you were thinking about adding hidden fees. So rather than having upfront pricing, you were going to have sort of hidden fees at the end. And this is something that customers hate. But it's actually been shown in experiment after experiment that customers, once you get them through the funnel, they're actually more likely to purchase with a fee sort of hidden at the end. But upfront, customers hate this experience. So you better be darn sure that you're getting a higher conversion rate, that you're getting higher profitability from these hidden fees, because you're degrading the customer experience. But if it's something fairly innocuous, like we're going to give them a different product recommendation, we're going to use a different font, we're going to use a different, style or background, you're usually willing to accept a higher level of uncertainty of no effect.